Welcome all. Through this video, we will familiarize with the pie charts. The function used for generating pie chart is plt.py. This is available in the matplotlib.pyplot module. The syntax is this: pie, then the wedge sizes, then xplot, labels, colors, and so many others are there. We will be looking at these arguments only. Pi of x, then xplot, then labels. Colors are also okay, you people know that. You can change these other variables, are straightforward, and I request you to try by yourself. Here x stands for the wedge sizes, and xplot will be explaining how xplot is used, and at that time, after watching that example, you will be very comfortable with this argument. And labels, you can label each wedge. Okay, so many controls are available with the keyword arguments, so you are requested to try all these things. Just an introduction to pie charts. What pie chart does is this: a circular region is divided into different wedges, wedge 1, wedge 2, and say wedge 3. Say this wedge may be labeled as, for example, number of students who secured different grades. Say A, B, and C. A, B, C, D are the grades. Let 10 students secured A grade, and 20 students secured B grade, and 30 students secured D grade. So, and some 40 students secured D grade for some particular exam. Then if you represent this information by some pie chart, it looks something like this. So how it is represented: total 10 plus 20, that is 30, 30 plus 30, that is 60, 60 plus 40, out of, there are 100 students. So 10% of them secured A grade. So 10% of them secured A grade. So the total area of the circle is divided into, that is pi r square is divided into how much area? Is divided into 4 areas in the ratio 10 is to 20 is to 30 is to 40. So this wedge occupies 10% of the area, 10% of the total area. This wedge will occupy 20% of the total area. Please note that this is only example. This division is not up to scale, and this wedge occupies some 30%, and this wedge occupies some 40%. Okay, so that is how we represent this data. Okay, you can say that the wedge angle is also, the wedge angles are also in the same ratio, 1 is to 2 is to 3 is to 4. So this is a simple way to represent the data. Okay, now if in some case if the sum is less than 1, if you consider, for instance, this is 0.1, this is 0.2, this is 0.3, and this is again 0.1, let it is 0.1. Then if you add up 0.1 plus 0.2, that is 0.3, 0.3 plus 0.3 is 0.6, 0.6 plus 0.1 is 0.7. So if it is 0.7, then what happens is it divides that in the ratio 10%, 20%, 30%, and again 10%. The remaining part will remain vacant. By exploding, we means in some cases explode. So how will you explode this thing? For instance, I wish to project the information that 10% of the students secured A grade. So for that, I can represent the information something like this. So this is the 0 line, 10%. Okay, so something like this. Okay, I take this part little bit out, and this concept is called exploding. So you'll explode this particular pie chart, and you can decide how much it must move away from the center. So this much distance has to be specified. If you specify the exploding distance as 0, it won't explode, it remains there itself. And if you give more distance, it will move more away from the center. So we'll see all these things, and labels are meant for this thing. In the previous example, the first group classified is labeled as A, then the next wedge is labeled as B, then the next wedge is labeled as C, and the next wedge is labeled as D, something like this. Okay, so this is how a pie chart is used to represent data. We will see this thing through some Python examples. Okay, now let us familiarize with this pie chart. For that, let us consider a batch processed a batch file. So I have already made one example. Now I just imported both NumPy and Matplot. So I imported them like this from matplotlib.pyplot import star. So this will import all the functions. Then from NumPy import star, that will import every functions available in NumPy. Now I gave labels as like this: A plus A, B plus B, C plus C, and D. These are the grades. I'm going to label them as A, B, C, D, etc. And I gave fractions. What fraction or what number of students have secured A plus? It's 5. How much students secured A? That is 8, and so on and so forth. Then I just call the pie function, which is available in the matplotlib.pyplot, and the first one must be the x data, that is wedge size. The wedge size is represented here as fractions, and then I gave the labels. Labels is the keyword or keyword. I gave the labels as labs, and I'm going to see the thing show. So let us try this. Okay, so this many students have secured. You can see this. Among them, 5 students have secured this thing. 8 students secured A, then 18 students B plus, so on and so forth. So this is the idea. Okay, we will now try this without applying the labels. So let us see how it looks like. Okay, you can see that there is no labels. Now there is another modification we have to discuss. We have to add one more argument, that is explode. So I wish to explode a particular point. I wish to make these things more important, that is how many students secured A plus. So the first item must explode to some distance, say 0.5 for 5 units away from the center. Then I wish to specify how much, or I need to stress this information, how many students secured D. All other things are normal, and I am going to make all others as 0. How many are there? 1, 2, 3, 4, 5, 6, and 7. Now it's 2, then 3, then 4, 5, then 6, 7. I wish to explode these things. Okay, so let us see. So I am going to explode the first wedge as well as the last wedge. Okay, those who have secured A plus as well as those who have secured D. Okay, you can see this. A exploded by some 0.5 units. That means we consider this as 1 unit by default. So 0.5 unit means halfway from the center, and this is more than that, 0.7, and all of this haven't exploded. You can try with the different values for this explode. Okay, now let us see what happens if the sum is less than say 0.1. So for that I wish to add some labels, some fractions, or let me just call them as x equals, I am going to comment this thing fracs. Okay, instead of that I am going to use some values, say 0.1 comma 0.2 comma 0.5. so there are only 3, and I'm going to make some labels as well. Labels equals, I have only three items. Now I call them as ABC, A comma B comma C. Okay, now I'm going to comment this thing. Okay, let me call it as L. Okay, let me call pi function pi of, instead of fraction I'm using x here, and as labels L, so labels equals L. So let's run the code. Oh sorry, there's a printing mistake, labels. So we'll see the result. Okay, please note that the entire area is not covered. Please see the values we have given 0.1, so 10% of the area is allotted for A, label A, and then to 0.2, that is 20% of the area is for B, and 0.5, that means 50% of the area is for C. So altogether 0.1, so 10 plus 20 plus 50, that is only 80%. The remaining part means 20% is kept empty. So this will happen only if the sum of all the x values is less than 0.1. all right, so there are so many control available using keyword arguments. I request you to try different arguments and obtain a pie chart according to your wish. So we have seen a simple example of pie chart, generating pie chart. I request you to try all the controls available in the pie function. So there are several keyword arguments, we have already mentioned them. So I request you to make some changes in the default values of all these keyword arguments and try to generate some plots and see the differences. Thank you.